Hi students! Today we're going to be talking about how to balance a skeleton equation. That basically means the same thing as saying how to write a chemical equation. I just wanted to give you an idea that we're talking about the chemical symbol equation, not the word equation that you guys have been working on earlier this week. So the equations and the examples that I'll be working with today are already written in chemical formulas, but eventually you will be required to go from a word equation directly to balancing it. So it's the word equation, then the skeleton equation in symbols, and finally we're able to balance it. Today we're just going to be focusing on that last step. Once we have the skeleton equation, how do we balance it? Okay, the most important thing to remember makes us recall the law of conservation of mass that says matter can neither be created or destroyed. Therefore, we know that the number of atoms of each element must be equal on both sides of the equation. That means something as small as one atom cannot be created or destroyed. So if it comes in on the left side of the equation, the reactant side, it's going to still be there on the product side or the right side of the equation. Now, two more steps just to tell us how we actually balance the equation. Well, I gave you a hint in here. Start with the largest subscript. Those are the small numbers we've been working with this week to write correct chemical formulas. Start with the largest subscript on either the left side of the equation or the right side. The left side we call in chemistry the reactant formula, and on the right side of the equation we refer to those as products. So a formula on the right side would of course be a product formula. And now we're down to how do we do it? Well, all you really need to do to balance the equation is write the coefficient in front of the formulas of compounds or symbols to balance the equation. What is a coefficient, you ask? Great question. A coefficient is a large number that can be written in front of the formula to be able to balance the equation. What I mean by that, we want to have equal number of atoms of each element on both sides of the equation. The way I've told my students in the past to remember this is think of a teeter-totter. If you're trying to balance a teeter-totter with your friends on the playground when you were in elementary school, you had to have equal number of bodies on both sides of the teeter-totter, or you had to have equal mass on both sides of the teeter-totter to get it to balance. Same thing in a chemical equation. We have to have equal number of atoms. Let's look at some examples, and I think this will be really simple for you to understand. The first example involves silver and oxygen. Silver plus oxygen gives us silver oxide. Notice that since these are on the left side of the equation, they would be called what? That's right, reactants. And notice because this is on the right side of the equation, it would be called what? Product. That is correct. So we're adding these things together and getting something new. So thus a chemical reaction has taken place. So if we want to balance the equation, we have to ask how many silver atoms are on the left side of the equation? That's right, there's one. How many silver atoms are on this side of the reaction? That's right, 2. So we see right off the bat, it's not equal, correct? So what could I do to make the number of atoms of silver equal on both sides of the equation? Yes, I could put a 2 in front of the silver formula, and that is called a coefficient, the large number. Now I can go back and change my check. This is what I refer to as, I know in math class you have mathematical checks that help you to see whether or not you got the correct answer. In science, I call this my science check. Now, as you get better at balancing equations, you will not need to do the check. You'll be able to do this in your head. But when you're first starting out, it helps make it clear. And some of you will get this very quickly and you won't need to do the check. And as soon as you're getting proficient answers and correct answers, I won't require you to show me the checks any longer. Now, we have another element on the left side equation, that is oxygen. How many atoms are on the left side? 2. And how many atoms are on the right side? 1. So that tells us we don't have equal number of atoms. Again, what can I do to make this a balanced equation? That's right, I can only put coefficients out in front. So now I have 2 atoms of oxygen, I'm done, right? No, you say? Very perceptive answer. When I put the 2 in front of my compounds, I change the number of atoms of silver. So now I have 2 molecules that have 2 atoms in each molecule. Therefore, that would make a total of 4 atoms of silver. So what can I do to balance this side of the equation? That's correct. We're going to have to go back and change this coefficient to 4. And I'm going to ask myself one more time to go through each step. How many silver atoms do I have? 4, 4. How many oxygen atoms do I have on the reactant side? 2. How many atoms of oxygen do I have on the right side? 2. I would like you to try to solve the next 2 examples on your own. Go ahead and pause the video, and then when you restart it, we'll go over the answers for example 2 and 3 together. And tomorrow in class, we're going to be working on a whole worksheet of problems that you'll be working on together as a group. I hope this has made sense to you, and I hope you come to class prepared. I'll see you in a few minutes when you finish these 2 examples.